Hello. So let me introduce nearest neighbor with a story. You can see there is a music class taking place here, and the music instructor asked every student to find a partner for himself for this class so they can sing together, and so one person can play a song and the other can play the instrument. So everyone has to find a partner for himself to take to participate in the class. Now the question for every student was how to find a partner for himself. Now there was a lot of things they thought of, but one thing which was the most important was that moving these instruments is not easy. So they want someone who is near to their house. So that way it will be easier for them to go to them on the weekend and play the music. Also, moving these instruments will be quite easy. So everyone wants their partner to be close to each other, and for that the distance between their houses must be very small, right? So that is what we want to do in the nearest neighbor, finding uh, finding a partner that is the nearest to us, right? So now, while doing this task, it was not easy because everyone has to ask every other student. So, for example, if I see this picture, for example, this red guy wants to find a partner who is closest to him. So for example, this guy is closest to him. Then he has to inquire this guy, this guy, this guy, this guy, this guy, and then he will find the nearest um, the nearest neighbor. But the problem is, even when he come to this guy, for example, he has to also inquire this guy because they may have they may be more nearer than him. So he has to actually ask every person in the class what's the distance to where is their what is the address of their houses, and eventually he will compute a distance for every person and then will pick one. And then similar for this guy, he will ask every other guy in the classroom, and this guy will also do the same. So they got a list of attendees in the class, and it looks something like this. So we have the name of the person, then the address, and the distance in the kilometers, right? Now this doesn't make sense right now, but it will in a moment. And what this means is that John is 26 kilometers away from the music class, for example, and Lisa is 32 kilometers away from the music class, and Katie is 42 kilometers, and Andre is 32, and Nina is 43. Now the problem is this attendee list. For example, John wants to find his partner. He has to go through all his classmates and find his nearest neighbor. Wouldn't it be nice if we have a list which was similar, but it had a new column, right? And it looks something like this. So, for example, John is closest to Lisa, and his neighbor is 8 kilometers away from him, right? And Lisa is the name of the person, and Andre is nearest to him, and Katie is the other person, and Nina is closest to her. And that way, with this list, now people can quickly know which person is closest to him, or who is the nearest neighbor of, for example, John, Lisa, Katie, and so on, right? Rather than going through all the list, now we have this new list which contains this summary information. So our task will be to convert this list to this list. And this is what will be done by the nearest neighbor algorithm, right? It will take distances of all the people or addresses of all the people and somehow compute the nearest neighbor. And remember, the strategy in the first attempt will be the same. We will take this person and compute the distances from him through all the people and then find the minimum and put it in the list. Then, for example, for the second person, we'll take him, we'll compute the distances to all the people, take the minimum and put the name of the person who is minimum and put the distance as well, and so on. Then we will do it for the third person, and finally we will get a new list which will contain the information of the nearest neighbors.